Students, let us solve this Irodov problem number 1.59. An aerostat of mass m starts coming down with a constant acceleration w. Determine the ballet's mass to be dumped for the aerostat to reach the upward acceleration of the same magnitude. The air drag is to be neglected. What is the question? There is a aerostat. What is aerostat? Let me see the figure of aerostat. This is called aerostat. There is a hot balloon of very big size connected to a load. Now, due to the buoyant force of air, there is a upward force on this balloon, and this buoyant force depends only on the volume of this balloon. So there is a load m, and initially this aerostat is going down with acceleration, constant acceleration w. Now what have happened? Some of the mass is thrown out. Let me see, call this m naught. M naught mass is thrown out from this aerostat. The remaining mass is m minus m naught. Due to this mass detachment, the acceleration of aerostat is upward in upward direction with same magnitude w. So we have to calculate the value of m naught. Now how to solve this problem? So initially, what are the forces? The mass of this block and with this balloon is m. So there is a downward force of gravity which is mg, and there is a buoyant force acting on the balloon, and it is equal to rho g and volume of balloon. Now I assume that the volume of balloon remains the same, and in the question there is no air drag, so there is no force of air drag. Now when m naught mass is detached from this system, the gravity is m minus m naught into g. This is the force due to gravity. What is the buoyant force? Buoyant force does not depend on the mass of this system. Buoyant force only depends on the volume of this balloon. So volume of this balloon remains the same. So the buoyant force is again rho g into v. Now one Newton's law equation from this figure and one Newton's law equation from this figure. Now let me see the equation. From this figure the equation is mg minus rho gv, force equal to mass into acceleration. Now what is the equation? The acceleration is in upward direction, so this force is greater than this force. Now the second equation becomes rho g v minus m minus m naught into g, force equal to mass into acceleration. So we have to calculate the value of m naught. Add these two equations. So this plus part is cancelled out by this minus part, and this mg part is cancelled out with this mg part, and this minus minus becomes plus. So m naught into g should be equal to 2mw. So m naught must be equal to 2mw divided by g. So this is the mass of ballets must be dumped from the aerostat for a constant acceleration w in upward direction. So this is the answer.